This conference will now be recorded.
Okay, hi friends, good morning. In this Business Intelligence Master Program, so in today's session, we are going to talk about Spark architecture and Spark SQL. Okay, so let's see. So in today's session, we are going to talk about introduction to Apache Spark ecosystem components. So first, we are going to understand what are the different modules we have in Spark. Okay, then we will talk about Spark operations. What are the different operations we can able to do in Spark? Okay, operation is nothing but a let's say you can able to filter out the records, you can able to transform the data, maybe you can add the new column, all those things. What all operations you can able to do? Let's say you can able to select few columns, you can add the extra column from the existing columns. Let's say if you have 10 columns, you can just select 5 columns. Maybe you have 10 columns, you can add one extra column. Okay, 11th column you can able to add. So that is one kind of operation, that is called a transformation. Next operation, you have something called action. Action means you want to understand the number of records, dot count. You want to preview the data, dot show. So there are different actions. So there are two types of operations we have in Spark. One is transformation, second one is action. We are going to talk about those things. And Spark features, what are the different features of Spark? In memory computation, the Spark main, the way Spark is very popular, the main advantage of the Spark is it is going to process data in memory instead of processing in disk. If you look at any service which is processing data in memory, it will be very fast compared to the engines which are processing data in a disk. Next, lazy evaluation. Lazy evaluation means lazy person. So when you heard about multiple times, you told your friends also, he is lazy, he is lazy, what it means. So when you instruct something, he will not do immediately. So they will do very maybe after 1 day or after 2 days. Sometimes they even may not do, right? So lazy evaluation means Spark will not execute the transformations until you apply the action. We talked about these things in Spark operations, right? There are two types of Spark operation. One is transformation, second one is the action. So lazy evaluation means transformation, adding the extra column, selecting only 5 columns out of 10. All these are the transformation, right? So these kind of things will not happen until you apply action. Action means if you apply count, if you apply maybe show, I want to preview the result, I want to understand the result count. So until unless you ask for something, these transformation will not execute. So it's a lazy evaluation. Then partitioning. So it's a cluster, Spark cluster. We are going to say Spark is not a single mission, it's a group of missions. So when you have a group of missions, what you need to do is you need to divide your data. If you have 100 records, you need to divide 100 records into 4 or 5 parts. It depends on your cluster configuration. If you have a 4 computers, 4 parts you need to divide 100 records. If you divide 100 records into 4 parts, it will be a 25, 25, 25, 25. If you divide into 20, 20, 20, 20, 20, 20. Sorry, if you divide into 5 parts, okay, you have 100 records. If you divide into 4, you will get each part, you will get a 25 records. So if you divide each part, like if you divide 100 records into 5 partitions, in each part you will get a 20 records, right? So we are going to partition this data. Why you need to divide data something like this? Because we have a group of computers in backend. Cluster is nothing but group of computers. So we have a group of computers. So what you wanted to do, you want to make sure that all the computers got the required task. Example, if you have a 4 workers, so what you need to do is you need to divide work among them. So in a project, if you look at, you will have a project team. So what is project team? So the people who are working for a common goal or same goal. So we all are going to work for a same goal, right? So what we will do, we will just we will work for completion of the project or delivering the project. But ultimately, we are going to divide the work to finish the project quickly. In the same way, whatever data processing it is going to do, it has to process quickly. For that, it is going to divide data and process it. Fault tolerance. Fault tolerance means in this process, let's say your friend is sick, your colleague is sick. so you may not be able to work on that particular day, right? In the same way, in computers, when these computers are processing the data, some of the computers may shut down due to some server issues, whatever issue, but servers may shut down, right? So if server shut down, what you can do is you can try to restart it. If that machine is not restarting, you can able to replace with a new machine. So that's how we can able to, in case of faults, whenever some problem comes, you can able to tolerate, you can able to replace the system, or you can able to restart the system. Spark APIs, so we have a different APIs, like you can write Spark code in a Python, Scala, SQL, R, and Java. We are going to talk about those things. Databricks supported APIs. Okay, Spark is going to support all those things, but Databricks will support all those things. Yes, Databricks also will support all those things. We'll discuss. Tools required to write code in Databricks. How you can write code in Databricks. We are going to see what are the tools we need to write code in Databricks. Then we are going to talk about Spark architecture, Spark transformations. Here I already mentioned, right? Spark operations are two: Spark transformations and action. So here I will just discuss Spark transformation. Then Databricks execution hierarchy. Databricks execution hierarchy, basically how this execution is going to happen. First it will create jobs, then it will create stages, then it will create something called task. Okay, all those things we'll see. Next, in this transformations also, we have two types of transformation: arrow transformation and Y transformation. We'll just look at these two types of transformation, and finally we are going to talk about lazy evaluation. Okay, so lazy evaluation I mentioned here, but here I'll just explain you with some examples. Okay, I'll just explain you with some example, because if I simply say lazy evaluation means this, theoretically you may not be able to understand. I have some pictures, so with that you can able to understand. Finally, I will show you how you can create Azure Databricks and how you can create the cluster in today's session. Okay, fine. Now you see introduction to Apache Spark ecosystem components. So in this, say Apache Spark ecosystem. So in this first module called Apache Spark Core API. So it is the only module which is available when Spark is introduced. Okay, so here objects are called RDDs. Objects are called RDDs. So this particular Spark code, you can write it in a Python, Scala, SQL, R, and Java. You can write this particular Spark code in Python, Scala, SQL, R, and Java. Next, so this is basically RDD. Okay, on top of it, we would have a Spark SQL, we have a Spark streaming, machine learning, and graphics. So you can able to handle machine learning models, you can able to analyze your graph objects. If you have any graph, you can able to process your real-time data, near real-time, meaning, so instead of storing data for one day and processing next day, so it is too delay, right? You will not be able to understand what is happening today. If you want to understand what is happening today, you need to wait up to tomorrow, isn't it? If you want to understand what has happened yesterday, you cannot know yesterday, you need to wait till today, isn't it? So that is the problem. That's why we have a Spark streaming. What Spark streaming will do, it will allow you to understand your business immediately. You will be up to date. Okay, what is happening? So to process data immediately, we have a Spark streaming. But Spark SQL, we have to process data in a batch. Batch means collect one day data or 1 week data or 1 month data and process it. So for that we have a Spark SQL. Okay, so now try to understand one thing. You have a three types of data. One is structured data. Structured means we have created RDBMS tables, isn't it? So in those tables you might have seen data, we have defined some columns, and in those columns we just inserted the data. So that is a structured data. If you want to insert some extra data, it is not possible, right? That is a structured data. Unstructured data, semi-structured data means if you have any Excel files. In the Excel file, you can have multiple sheets, isn't it? So, but each sheet can have a multiple number of columns. We are not sure whether all the sheets are going to have a same number of columns or not. That is completely depends on the business. It's a semi-structured. So if you consider each sheet, it will be a structure, but when you look at the multiple sheets, it will look like a semi-structure. But unstructured means if you look at any audio, video, image files, those are those will come under unstructured data. Now you see here you have a Spark SQL. Spark SQL is basically recommended. It's just a recommended, but if you want to see, you can handle these three types of data by using Spark Core, by using Spark SQL. Okay, these are a different purpose, right? For processing data, near real-time data, meaning whenever data comes immediately, if you want to process, to develop machine learning model, to analyze graph object. But these two are important. So because these two only we are going to use in these three. Okay, so you need to be aware of these two. But as I mentioned, you have three types of data sets. Those three types of data sets you can handle here or here. But Spark Core is recommended to handle only unstructured data. It's a recommended, but you can handle any types of data. Spark SQL is recommended to handle structured and semi-structured data. Okay, so you should be aware. Spark SQL is structured and semi-structured data we are going to handle. Spark Core we are going to use for unstructured data, but we can use for any other thing, but it is not recommended. Why it is not recommended, I will show you practically, so you will see the difference. Okay, next, Spark operations. See, as I mentioned, there are two types of Spark operations. We have transformations and actions. Okay, just to click on this, you see here there are two operations performed on RDDs. Okay, so RDDs are the very basic object in our Spark. RDDs are the basic objects in Spark. Okay, so there are two operations performed on RDDs. One is transformation, second one is called action. Okay, what is transformation? You are transforming something. Okay, you are transforming something. We have a 5 columns. You are adding one extra column. Maybe you are removing the some of the records. Okay, drop duplicates you are doing, you are just removing the some of the records. Maybe you are just you are dropping some of the columns, you are just selecting some of the columns, you are applying join and you are getting the completely new data. So all these are a transformations. You want to filter out some of the records, you want to modify the data. Maybe you have credit score. Okay, credit score we were handling, right? So credit scores we have something 900,000, something like that. For that I want to add bonus points. So for all the people who has credit score less than 1,000, for them I will add 10 bonus point. Greater than 1,000 credit score people, I will give the bonus points 20. So if you want to add all these things to the data, all these are transformations. But after applying the transformation, after adding these bonus points, what is the result I want to see? So that is nothing but action. You see, transformation, it is a function that produces new RDD from the existing RDD. So when you create whenever you apply a transformation, it will create the new data object. Example, let's say you have 5 columns. Okay, so now you are selecting 3 columns. If you select 3 columns, with the 3 columns object will be created. Okay, what is object? So there are multiple objects. We have core. I have explained you down, we have a core, right, in previous slide. That in the core, if you are using a Spark core to create any object, that object is called a RDD. That object is called RDD. But if you create any object in a Spark SQL, okay, that is the like top first one. So in that, objects are called data frames. And 98% we are going to use the data frames. RDDs are we are not going to use much. Okay, I'll discuss next. It is a function that produces new RDD from an existing RDD. Okay, transformation. Action, you see, in transformation RDDs are created from each other. So first you have read the file. In the file you have 5 columns. Okay, with 5 columns you created the RDD. Later you selected only 3 columns. With these 3 columns new RDD is created. Again you are adding one more column. Now you have 4 columns. With that you will get the RDD2. Now you have RDD1, RDD2, isn't it? So whenever you apply a transformation, RDDs are creating. But now you see, when we want to work with the actual data set, then at the point we can use the action. What it means is, now let's say you want to understand the result, you want to understand the current data, you want to preview, or you want to know the maybe top 5 records. Okay, so maybe you want to know first record, you want to check whether is it empty or it is having some data in this object. So all these things, if you want to understand, you need to use the actions. Okay, so Spark is a lazy evaluation. What it means, these transformations it will not execute until you apply action. These transformations will not execute until you apply action. I will show you practically. Next, Spark future. Spark is very high speed. The main reason for Spark to be speed is it is going to process data in the memory. So in memory computation, so whatever it do, it is going to use completely memory for computation. That's why it is speed, real-time stream processing. So before, so when big data came into the picture and the people started processing this big data, we have a something called MapReduce, Hadoop. So in Hadoop, the main disadvantage of Hadoop is we are going to process data in the disk. If you process data in the disk, yes, Spark is a open source. Okay, so try to understand it's a real-time stream processing. What it means is in Hadoop, right? So we cannot process data immediately. We need to wait more time because it is going to process data based on a disk. So all the computation, like, so it is going to use the disk for processing your data. So when it is going to use the disk for storing your intermediate results and all those things, it will take more time. So that's why your MapReduce is not suitable. Then we have a Spark introduced. This Spark can able to process your data immediately, or you want to process like daily one time. So whatever data you collected yesterday, entire data you want to process today, that is also possible. Lazy evaluation, as I mentioned just now, transformations will not execute until you apply action. Okay, next. Support multiple languages. So Spark supports multiple languages. Suppose if you know SQL, you can write it in SQL. If you know Python, you can write it in the Python. If you know Scala, you can write it in a Scala. Okay, and you can write it in a Java as well. Persistence means it is going to use the memory, right? So what you can do, your result, you can store it in a memory. You can able to store it in a memory. So whenever you want to read some data, you no need to read it from the disk. It is going to take more time. So instead, you can use the you can able to store data in the memory. From the memory, you can able to read this data. It will be much more faster. Fault tolerance. This is also explained. Fault tolerance means it's a cluster group of computers. If some computer is down, you can able to, that is the problem. If some computer is down means that is the fault. That fault we should be able to tolerate. How to tolerate is, how to tolerate is what you need to do. You need to restart the computer or you need to replace the new computer. Okay, partitioning, as I mentioned, as you have a group of computers, you need to divide the task. When you have 100 records, you need to divide into partitions, chunks, right? Those chunks you need to submit on a one computer. Next, parallelism. So as you know, so now you have 100 records, you divide it into 4 partitions, 25, 25, 25. Now all these partitions are going to run parallelly. So that's how you can able to process data quickly. You have a parallelism here. Okay. Any doubts in this Spark features? Any questions friends here? So in memory computation. So in memory computation means you see what happens. You will read data from the disk. See, it is in Hadoop. You will read data from the disk. You will apply some transformation. Result you are going to store it in a again disk. You will apply next transformation, store result in a disk. Apply next transformation, store result in a disk. So this is every time it is going to use a disk. That's why it will take more time. Okay, move data through disk and the network, so it will be slow. So you see here, users can cache data in memory, meaning, so first you read data from disk, next it is going to use the memory. So so whenever you say 1 plus 2, it is 3 basically, right? What it will do, it will try to use the memory for all of this. It will try to use the memory. Okay, it will try to use the memory for these calculations, because if you are doing some calculation in memory, it will be much more faster. So that's why you need to understand. So when you apply first transformation, when you read the data, it will load it into memory. Then you can apply next transformation, load it into memory, next transformation, load it into memory. So every time you can able to store it in memory. That's why it will be much more faster compared to the disk. So this is the in-memory computation means. Okay, next, lazy evaluation. You try to understand. See, you have all these pictures, right? So what it indicates, you, until unless you apply, see, all these are the DAGs. So this is a DAG visualization, direct acyclic graph. It knows Spark will not execute any of this. It will just remember, okay, first it need to read the data, then it need to transform this data, then it is basically join of these two tables, then it is going to do some aggregations. Okay, so final aggregations, maybe user want to see that particular result. Now these all are going to remember. Spark will remember what it needs to do. Spark will remember what it needs to do. But ultimately, when you look at here, when you say dot collect, then it will start, okay, read these two files, then apply this transformation, then join these two tables, then apply some aggregations. Okay, then it will show the result. But and if you're not executing this execution steps, it will remember like this, and it will not execute any of this. Okay, when you apply action here, this is the triggering point. When you apply action, it will start reading these two files, applying transformation on these two RDs, then joining these two, applying aggregation. Everything will execute when you apply action here. That's why it's a lazy evaluation. I'll show you more in detail in upcoming slides. You see partitioning, how data will be partitions. So we just discussed the Spark futures, but I'm just in detail describing what it is, each one. Partitioning, you see, you have 25 items. Now, this particular worker can take up 2 tasks. This particular computer can take two tasks. This computer can take 1 task. So you divided this entire data into 5 parts. We have total 25 records. You divided these 25 records into 5 partitions, 5 parts. 1 and 3 partition submitted in first computer, second and fifth partition you submitted on second computer, and fourth partition you submitted on the third computer. So this is how it is going to process data in a partitions with parallelism. So because all these computers are going to execute this data parallelly. Next, fault tolerance. See, fault tolerance means you just read the data, processed. Okay, you process. We have data here, and again you process data here. Again, your process data is here. This computer is down now. Okay, due to some reason, this computer is down. What will happen? You will lose this particular part of the data. So, how to avoid losing this part of the data is what you need to do for this. You need to restart this computer, or what else you can do is, if this particular computer is not coming up, you can able to replace the new computer. So that's how you can able to process this part of the data. That's how we need to process this data. Okay, so here we have a user. Understood? This is how, if so you have a group of computers, out of which one computer may be down, so you try to restart it. If it is not restarting, replace it. Spark APIs. Spark supports Scala, Python, R, and the Java, friends. Okay, but in Databricks supported APIs, in notebooks we can write Python, Scala, SQL, R code. In Python files, we can able to write Python code in jar. Jar means Java archive. So if you have any Scala in Java code, you can able to use jar. See, notebook supports Python, Scala, SQL, R. So what is this notebook all about? Is it's a interactive. You just say, you just submit some command, you immediately will get the result. You just write something, you will get the result immediately. That is the notebook. But Python file, jar file means entire code will execute at once. But in notebook, bit and pieces you can able to execute and check the result. Next. So tools required to write code in Databricks is, if you want to write Scala and Java, you can use Eclipse or IntelliJ. But for writing Python code, you can use PyCharm. But we are not going to use this Python files and all these things because it's not required for us. Mostly 99% people are using notebooks because that is the easiest one to understand the result immediately. Okay, but if you want to use as a batch entire code, if you want to execute at once, you need to write that entire code in your file. To write that into one file, you are going to use tools like Eclipse, IntelliJ, and PyCharm. Okay, depends on what language you want to write. So notebook supports Python, Scala, R, and SQL as I mentioned. Now Spark architecture, you see, before I explain Spark architecture, I will tell you something. Let's say you have some function. What you need to do for this, you will just go to some organizer who will decorate all the function hall and all those things, right? He is a manager. Your job is to give the instructions to the manager. Manager may request the related people for the resources. Okay, manager may request the person for the resources. Whom he will request, we don't care. So maybe a resource manager who will manage the workers. You know, for nowadays, like for workers, worker manager is also there, isn't it? So you can call him as a resource manager. What this resource manager will do, he will manage some 10 people. Now this manager decoration you need to do, right? For this, what this manager will do, this manager will ask resource manager, hey resource manager, you have a lot of people, right? I need at least 2 people. Can you send those 2 people to me? Yes, sorry friends, you understood. See, again I'm explaining. So I want to organize a function. I will contact one manager for my functional decoration. This manager will contact resource manager who will maintain the workers, actual working people. What this manager will ask resource manager is, hey manager, I need 2 people for this particular decoration. Now this resource manager, what it will do, it will send those 2 people. Then your manager will tell, okay, this person has given this task, can you just do this task? Actually workers will execute these things. Once workers is executed this, workers will report directly to us. Okay, because we have given the task, so workers will give the instructions to the us, instructions back to us. Example, with that exact context you try to understand here. This is a driver program. Okay, to this driver program, what is there in this driver program? You will have a Spark session, Spark context, you will have something like this. But try to understand in this driver program. Okay, so driver program is nothing but, let's say I am the actual manager who is organizing the function. So I will go and talk to this driver manager. Hey driver manager, can you just do 1 plus 2? Can you do 1 plus 2 and tell me what is the result? What driver program will do, you will first interact with the cluster manager, or you can say resource manager, who will give the resources for you to do this particular task. 1 plus 2 how much? right? This, as per driver program instructions, cluster manager will start workers. Okay, inside workers will have executors and task executors and task executors and task. What is executor and task? I will explain. Executor task will have. You understood? So this is one worker, there is another worker. Cluster manager has given two workers for driver program. What driver program will do? Driver program will give the instructions to the worker nodes. Okay. Now driver program, how driver program knows what to do? I will submit my code. I will submit my code on driver program. So driver program will come to know what it has to do. So with this, it asked cluster manager launch two workers. Now this driver program will give the instructions to the worker nodes what it has to do. These workers will execute that and give the result back to the driver program. Give the result back to the driver program. This driver program will give us a result. Okay, when I do 1 plus 2, this is the result 3. Okay, so you have given decoration task. Yes sir, decoration task is completed. You are going to report to us, isn't it? So likewise, we have a driver program who will take the actual task, and based on the task it will ask cluster manager to start the workers will be started. Now we are going to submit our task on the workers, because actual people who are going to execute the job is workers. So then you will just send it back to that result, you can send it back to the driver program. You can send it back to the driver program. Okay, yeah, this is how the things will work. Now what is the executor? See, in every computer, we will have something called Java Virtual Machine, JVM. That JVM, I need to divide into three parts. So that JVM, I will divide it into three parts for the multitasking or processing. Okay, I don't want to use my entire JVM as a single person. I want to divide my JVM into three different parts to execute three different processes at a time. So I divided my JVM into three parts, that is called executor. In each executor, you can have you can submit the task. Task means we talked about partitions. One partitions can be submitted on a one task. So this executor can able to execute 5 tasks, means you can able to submit 5 partitions on this, 5 partitions on this, 5 partitions on this. With this, total 15 partitions we can submit on this single worker node. In the same way, 15 partitions we can able to execute on this particular single computer. Okay, this is the Spark architecture. Any questions in this? If no question, let me just move on. Spark transformation, try to understand. Spark transformation is a function that produces new RDD from the existing RDD. It takes RDD as input, produce one or more RDD as output. Each time it creates new RDD when we apply any transformation. This is what we discussed, right? Whenever we apply transformation, it is going to give the new object. That object may be RDD or data frame. So there are two types of transformation, narrow transformation and wide transformation. We have two types of transformation. One is narrow transformation, second one is wide transformation. Okay, so we'll just quickly discuss about what is narrow transformation and what is wide transformation. You see, yeah, before I show you narrow transformation and wide transformation, what it is, you try to understand Databricks execution hierarchy. In Databricks execution hierarchy, so you'll have an application. When you submit, it is going to create a job one. In this, it is going to create a stage one. Inside stage one, you'll have a task one, task two. Inside job one, it may create stage two. Here you will have a task one, task two. In the same way, after this, it may create a job two. In that, it may create stage three, task one, task two, stage four, task one, task two, right? So now I want to understand when these jobs are going to create, when these stages are going to create. Okay, so fine. Let's say here narrow transformation example. So first, let's see what is narrow transformation. I have here some data. So here I have 3 records, here I have 3 records, here I have 2 records. So this is my driver program. On this driver program I will submit my application code. So when I submit my application code on this, I'm going to instruct what it has to do. So driver program internally, it has like it interacted with cluster manager. Cluster manager started these three workers. Okay, now on this application code I submitted in a driver program. Driver program will give the instructions to these workers. What instructions it will give to these workers? So read the data from where? So this partition you read, this partition you read, this partition you read. But will it really reading the data? No, it will not read the data, remember, but it knows first it has to read the data. So I explained a DAG, with the help of DAG it remembers. Next I want to filter out Krishna record. So in this we have Krishna record or not? Yes. See, same, it read these three records. Next transformation is filter out. Okay, next transformation is filter Krishna. So in this, if you filter Krishna, you'll get one record. In this, if you filter Krishna, you'll get one record. In this, if you filter Krishna, you'll get one record. So now these will not happen. Reading data, filtering will not happen until action is triggered. Now I'm going to apply action. When I say count, so then it will start reading data. Okay, 332 records it read. So these three records it submitted on this, these three submitted on this, these two submitted on this. So it is going to filter out. Out of these three, result is one. Out of these three, result is one. Out of these two, result is one. So count result equal to 3. The count value equal to 3 it will give, because 1 plus 1 plus 1. But when it is started reading, when it is started applying filter, when it is giving this result, when you apply action, so reading data, filtering, these are transformations. This is basically action. Understood? So now what happens? Whatever three records we have here, those three records only came here. Whatever three records we have, those three records only moved to the, see, this is a computer one. This computer read the data. Same computer is going to filter out the records, Krishna records. It is going to filter out. Same computer is going to do all the transformations. Okay, it is not another computer which is going to launch. Same computer, first it will read, then it is going to filter out the records. The result equal to 3. Now what you need to understand, the records which you read, same records, on same records you are applying the filter, on same records you are applying the filter, but you are not getting some of the records from this worker to this worker, right? From this computer to this computer, you are not getting the records. You try to understand. So this is called a narrow transformation. In narrow transformation, only one stage will be created. Only stage one will be created. Let's talk about Spark lazy evaluation. Okay, lazy evaluation in Spark means that the execution will not start until an action is triggered. Okay, transformations are lazy in nature, meaning when we call. So just now we discussed, right? So when you apply the action, then only transformations are executing. Understood? So this all, how it will remember the transformation with the help of DAG. That is what this theory all about. Now see, lazy evaluation, exactly it is going to do the same. Driver, you submit on this worker nodes, you will read the data, filter Krishna record. So when you apply action, then only it is going to read the data, filter out these records, and it will give the result. Okay? Result equal to 3. Understood? You understood, friends, here? Okay, in
Yes,
this
sir.
also, like only stage one will be created. Okay, now we'll talk about what is void transformation. Just to give me a minute. Yeah, you see, friends, it's a narrow transformation already completed, right? Let's talk about wide transformation example. You see, you have this data now, driver, you submit the application code, worker nodes, you are giving the instruction to read the data. But this time the transformation I'm going to apply is group by month. Okay, group by month. So in that case, can you check? So group by month means, so all the January records should come here, all the February records should go here, all the March records should go here. In this, can you tell me, do I need to move the some of the records from this computer to this computer, this computer to this computer, this computer to this computer, this computer to this computer? This kind of shuffling is going to happen or not? Will it be there, like whatever these three records you read it from this computer, so those will be passed to same computer, or you are going to move some of the records to the another computers? Yes, in this particular case you are going to move some of the records to the another computers. The reason is it's a group by month. All the same group records will be there at a one place. See, you have month is Jan chart. All January records will be here. So February card you read it. This mission read the February card. That February card should be passed to this. Understood? Now, in this we have read the February cards and March records. So February cards will two records will come here. March record should go here. Meaning, so here also maybe some records may come here, some records may come here. So what will happen? Some of the records may split like this. So from worker to also records may split like this. Some of the records may split like this from this worker 3. This is called a shuffling. So previously data is plainly moving from this computer to this computer only, but now data is moving from this computer to this. Now when you apply count, maybe whatever action, now it will start reading the data. It will apply this group by. When it apply the group by, so Jan you will get 2, February will get 3, March will get 3. So final result is something like this: Jan 2, Feb 3, March 3. You will get something like this, right? So when you just take the count of the records, how many records you have? You'll have a 3 records. Jan to Feb 3, March 3, total 1, 2, 3 rows you have, 3 records. Count if you apply 3 you will get. But if you want to see the result, you will see Jan to Feb 3, March 3 records will have. This is a Y transformation. In Y transformation, what will happen? So for till here, this is a stage 1. So this is called a stage 2. This another part is called a stage 2. This will be stage 2, friends. Okay. Any questions? Okay, so these are the slides I have. So let's see now how to create Azure Databricks Workspace. Okay, so fine friends, let's see now how to create Azure Databricks Workspace. Let me just open this Pro. Here you can say portal.azure.com. Okay, I'm here. Just click on Azure Databricks, or you can search here. Okay, here you can search for Azure Databricks. Okay, you search here Databricks, so you will get a Azure Databricks. Say Azure Databricks, just click on that, you will come here. So once you come here, just click add to create the Azure Databricks. So this is the subscription resource group name. Let's create a new resource group. Cloud Pandit Databricks Master Program. Click OK. And workspace name I can say Cloud Pandit Cloud Pandit, sorry, ADB. Okay, Cloud Pandit ADB, region is East US, pricing tier is standard. So we have a, see, you know all of these options, pricing tier is basically tells you, so what features you want. You want more control on Databricks Workspace, you need to go with the premium. If you want just basic things, you can go with standard. 14 days free trial means it's basically free for 14 days. Okay, let's go with the standard, then click networking. So do you want to launch your Databricks in your virtual network? This is for security. So I don't want to launch my Databricks workspace in virtual network, and whenever you are connecting to the on-premise services and all, you need to launch it in a VNet. For now, just click tags, click review plus create, validating. So once validation is finished, we can able to create this particular Databricks workspace. Click create to create the Databricks workspace. Now come here, click on resource groups to see what all groups we have. Only this is the one we have. Now this is the resource group it is going to create. In that, let's see all the resources which we have. See, when I create a Databricks, in backend it is going to create a lot of resources. We will see all those things. Currently we don't have anything. I just created Azure Databricks. It is going to create a lot of resources in backend for storing some data, like Databricks cluster information, Databricks metadata information, all those things to store. This Azure Databricks is going to create its own blob storage, its own virtual network, its own security group, its own network watcher, multiple things it is going to create. We'll see. See, it's created the Databricks workspace. Workspace is still creating. So to finish workspace, it also needs to create storage and security group, virtual network, all those things we'll see. Just wait for 2 minutes, you will see all those things here. Just refresh this to see all those things. So it's create a network security group, virtual network. Now it is also going to create a storage and other stuff. Let's see. See here, this is the storage account it has created. Okay, this is the storage account it has created. Now let's click on this Databricks workspace. Click. Yeah, it is still creating. It has not finished. Just refresh this. Yeah, so still it is creating all the other things. See, network watcher, storage account it has created, network security group, virtual network. So it is going to create all these things. See, now deployment is succeeded. Just to click on this. So once you click on this Azure Databricks, we have something launch workspace. Just click launch workspace. So this is your Databricks workspace. Okay. So in this, you see, let's create a cluster first. By the time cluster is created, I will explain all these options. Click on clusters option. In this tab, see it's a in the cloud. You are going to get a group of computers. So the symbol indicates, right? So we have a three types of clusters. Okay, sorry, two types of clusters: all-purpose cluster and job cluster. Job cluster will be created automatically. All purpose cluster you should create. Okay, how to create all purpose cluster? Click create cluster. This is a cluster name. Just give the cluster name. Cluster mode. So you want high concurrency, standard, and single node. High concurrency is basically for executing your jobs parallelly. Standard you can use to execute your jobs sequentially, but high concurrency is only supported for Python and the SQL. Okay, not for Scala. Okay. Now one more change that you see is when I say high concurrency, you will see terminate after 0 minutes of inactivity. So meaning there is no termination option available for high concurrency. Okay, but if you select standard, say automatically 120 minutes of inactivity. What it means, the standard missions, all the computers which are created here, those computers will be stopped after 120 minutes of inactivity. So if you are not submitting any job on these computers are going to be ideal. So when these are idle for 120 minutes, that is nothing but 2 hours, these clusters will be terminate after 120 minutes of inactivity. But if it is high concurrency, that option will not be available. If some interviewer asked you this, please explain. Single node means it's a one computer will get, it's not multiple computers. But standard means multiple computers. You see how many missions you need, two to eight. So if I have small data to process, use 2. If I have lot of data to process, use up to 8. Okay, even high concurrence we have this option, but when I select single node, it's a single computer. So you no need to set 2 and 8. It's a ultimately single computer you are selecting. Single node. Okay, pool means if you want to take, instead of taking the computer and starting by yourself, you can see some of the computers which are running in the pool. You keep running some computers in the pool. Whenever you want computer, you can just take the running computer instead of taking computer starting by yourself. Okay, Databricks runtime version means what all modules you need. Do you want to execute a machine learning? Then ML you can select. If you want to handle your biomedical data, you have a genomic something. If you want general purpose data engineering stuff, you can just go with 7.5 or 7.4. These things, the different versions. But normal 7.5, 7.4 means general purpose. But if you say 7.5 ML, graphical GPU will get, but here 7.5 without GPU. Okay, so there are different options. So based on your requirement, you need to select. The runtime means basic core components you are going to install in this. Okay. Okay, friends. So core components we need to install on a computer. Okay. So this is basically node configuration. What kind of computer I need? 14 GB memory, 4 cores computer I need. 4 cores means 4 CPUs. Okay. So with this configuration, click create cluster to create the cluster. Now cluster will be created in next 4 to 5 minutes. Okay. Next, click on workspace. See, I'll just explain all these different options. This is workspace where you can able to see the different links, common tasks. We have a notebooks you can create tables, you can create cluster, you can create jobs, all those things we will discuss. This is a single place where you can able to access everything. But if you click on home, you have just, you can able to create folders, you can able to create folders, then you can create the notebook. Okay, let's create a folder. This is a cloud pandit. A Cloud Pandit demo folder. In this Cloud Pandit demo folder, I want to create a notebook. Okay, create notebook. I'll say Spark demo. Okay. So in which language you want to write the code? See, notebook supports Python, Scala, SQL, and all. Let's select Python code. Click create. Okay, this is how I have created the notebook. This notebook you can able to attach to the cluster which you have created. click on this. It is the one which I have created. You can attach it, and then I have written I have executed all the code. You are already experienced with these cells, right? But how to execute all those things, I will explain you now. So this is how I have created the notebook. This is how I have created the cluster. Now, recent means recently accessed notebooks will be available. See, recently accessed notebook is Spark Demo. Data means if you want to upload some data, just click on data, create table, browse it, and I want to upload some data. Click on desktop, empty dot, not empty dot CSV. Let's go to cloud connected assets, comma separated files. Maybe you can say results.csv. Click on this. It is going to upload. Okay, so this is the data is uploaded. Where data is uploaded into this particular path. How to access this path? Click on dbfs, Databricks file system, file store, click on tables. Here you will see results.csv. Okay, if you want to preview this data, click on create table with UI. Create table with UI. You can select. So you don't have any running cluster. So once the cluster is up, you can able to attach that cluster and you can able to preview the data which you have in this. Otherwise, you can able to read this particular file directly in a notebook. Okay. So how to read this particular file in a notebook directly is click on this create table in notebook. So automatically notebook is created. So this is the file which we have uploaded. For this, it has generated the code. So you no need to write the code. But even if you want to execute this particular code, you need to attach this notebook to the cluster. Click attach. So now how many notebooks attached to this cluster? 2. How to see that? Click on clusters. Click on this. Go to notebooks. So it will show here once the cluster is up, it will show okay, there are 2 notebooks attached to it. Okay. Try to understand this. Next, jobs is basically to schedule any job. If you want to schedule job, you can able to schedule any job here. If you want to search for any notebook, you can able to search notebook here. Okay, let's say I have created Spark demo. I want to search. Yes, you can able to search it. Model is basically for maintaining the machine learning models. You don't worry about that. But now cluster is still creating. Once cluster is up, I can click on this recently accessed notebooks. Everything is available. Let's first click on the Spark demo. See, cluster is up now. I want to execute. What I want to execute? A equal to 10. Execute it. Say attaching to cluster. So if it is taking more time, do one thing, just detach from the cluster, okay, and reattach. So it will be much more quicker. Just execute it now. See, waiting to run. So running command, it is executed. Now I want to access A, just put A and execute. But how I am executing, you see, shortcut is shift plus enter to run. This is the one way. Second way is click on this, click run cell. Okay, select here, click run cell. So if you want to execute particular cell, if you want to run all, just click run all cells. Now go to another notebook, which is this. I want to read the file which I have uploaded. Just execute this. This is the command you just executed. So it will show you the data which you have uploaded. So here also it is saying attaching to cluster. Attaching to cluster, do one thing. Detach from the cluster. Okay, so detach, reattach. Instead of that, you can say here detach and reattach automatically at one shot. You can able to do both. Execute it now. See running command. It is running the command. It will display the data which we have. See, this is the data. But the problem with this is headers are going into the data. For that, you need to make small change. That is, you need to say this. Execute it now. You'll see data will be proper. Okay, I will explain you how to read the files, all those things in tomorrow's session. Okay. So today we just learned how to create cluster, how to create Azure Databricks, the basics of Spark. Tomorrow we'll start with the data frames, different types of files, how to read, how to install the libraries, all those things. We will see tomorrow. Okay, any questions, friends? Anybody have any questions? If no questions, that's all for today, friends. Thank you. Thank you.